Hello learners, this is your chemistry tutor Charles Kwame Bando. It's good to come to your way again. We met on Unit 1, and as I told you, I'm presenting or I'm handling this course with Mr. Stephen Kwame Amaku. So we met in Unit 1 and he also handled Unit 2, and I have come again to you on Unit 3. And so before I continue, I want to make a slight change in my presentation in Unit 1. On the slide that contains the Dalton's atomic theory, when I was about to exit from that slide into the Bohr's model of the atom, I mentioned the Dalton's atomic theory as the summary rather of the Bohr's model, which was something that I want to draw attention to. So when you are playing the video for a study purpose, make sure that you make that change. Thank you very much for understanding. Right, so today we want to look at Unit 3 of our general chemistry. And in Unit 3 we are looking at the mole as a unit and then formula mass. Of course, I've been telling you that this is not a new thing to you. It's the integrated science chemistry, the chemistry aspect of interscience that you did before coming to the college. So don't see this as new course standing somewhere and you are coming to. It's something you know already and we are only doing sort of revision. So have that confidence that you'll be able to do this and do it well. Right, let us look at our lesson objective that today you call it performance indicators. And so we are saying that by the end of the lesson, you as the learner that you are watching me should be able to define the mole as a unit. There again, you should be able to relate the mole to amount of substance and the number of entities or particles, basically the atom, the molecule, the ion and the electron. You should also be able to use the relative atomic masses of one mole of a given compound to calculate the formula mass, basically the molar mass. And these are the compounds that have been given. That does not mean that this is the only thing that we'll be doing. So we have carbon dioxide, water, sodium chloride, and then sugar. Right. Now the question that we want to ask ourselves that what then is the mole? What then is the mole? And you bear witness that this subject is the same thing that you did before coming. And so we are saying that the mole is nothing but the amount of substance which contains the same number of elementary particles as the number of atoms contained in 12 grams of carbon 12 isotope. Right, in our Unit 1 we spoke about what we mean by isotopes. And so we have taken one isotope of carbon as our reference material. And so we are saying that if we say the mole, it is referring to any amount of a particular substance that contains number of a particular particles, which is the same as the number of particles in 12 grams of carbon 12 isotope. So what does it mean that when I pick 12 grams of carbon 12 isotope, the number of carbon particles or carbon atom that will be in that particular isotope, 12 grams of that particular isotope, will be equal to the 1 mole of any substance. And then again, we are saying that in those of you who have been to the markets and other places, you hear dozen. And then those of you who are Bible readers also hear or see the word score in the book of Job. You see that 70. So what then do we mean by score? Score means 20 items, and then dozen also for 12 items, and then pair also for 2. So we are saying that the same way, mole is also a collection of 6.02 times 10 to the power 23 particles. And this number is referred to as Avogadro's number. This number is referred to as Avogadro's number. So we are saying that if you say a mole, A mole is nothing but just 6.02 particles. So times 10 to the power 20 times 10 to the power 23 particles. And so if you are saying a mole of sugar, a mole of salt, or a mole of water, then you are only talking about 6.02 times 10 to the power 23 molecules of water in that particular quantity. And that number is called Avogadro's number. So let's look at some basic facts about the mole that you know already, that I'm only reminding you. We are saying that if you remember your measurement, one of the things that they told us or you learned is that the mole is the unit of measure for amount of substance. Just as kilogram is the unit of measure for mass, so the mole is also the unit of measure for amount of substance. We also added that 1 mole of any substance, as we saw per the definition of the mole or per the previous slides, 1 mole of any substance contains 6.02 times 10 to the power 23 particles of that particular substance. Right, so we also added that 1 mole of every substance is represented by its chemical formula. So anytime you see a chemical formula of a substance, it represents 1 mole when there is nothing attached. For instance, if you see NaCl, it represents 1 mole of that particular substance. But if you see 2 NaCl, then that is not 1 mole, but it becomes 2 moles of that particular. So if you see CO2, if you see H2SO4 for sulfuric acid, it is representing 1 mole of that particular substance, right? Now there's this we call relative atomic mass. Relative atomic mass. Please let me remind you that anytime you see the word relative attached to a substance or a particular quantity, then you should bear in mind that that quantity will not have a unit. It means you are comparing that quantity to another quantity of the same unit. So there will be no unit attached to that particular quantity. So here the word relative is making sense that we are comparing the mass of any atom or element to 1/12 the mass of carbon-12 isotope. Right, so we are saying the relative atomic mass of an atom of any element is equal to 1/12 the mass of one atom of carbon-12. So here again, we are using carbon-12 isotope as a basis for our comparison. So we are saying that if you say relative atomic mass of any atom, then you only comparing that particular atom to the mass of one atom of carbon-12, right? And so we are saying that you can also define as the average mass of one atom of an element compared with 1/12 the mass of one atom of carbon-12. So you are just making comparison between that particular atom and that of carbon-12. We saw this in unit 1. Right. Now we'll look at relative molecular mass in detail, but here we only say that relative molecular mass is, you just calculate it from the atomic masses that makes up the molecule of that particular compound. We'll look at that, so don't worry here. So we will look at relative molecular mass in detail, so this is just reading information. Now we also adding that the mass of 1 mole of every substance is the sum of relative atomic masses of all the atoms in that particular formula. We will look at this also when we are doing calculation for relative molecular mass or the molar mass as well. Alright, so we are saying it is also known as formula mass. These are just reading information that I'm giving you. Now we will look at solution in detail, so don't let us spend much time here. We'll look at concentration of solutions and then we will go. So here we will also add in the relative molecular mass, or molecular mass is the sum of the atomic masses of the atoms in a particular molecule. We'll look at this. Right. Now what you should take a note here that the relative molecular mass has no unit, but molecular mass has a unit. However, they have the same numerical value. What we mean here is that both quantities are quantitatively the same, but qualitatively they are not the same, because relative molecular mass, because we are comparing it with carbon-12, it has no unit, but molecular mass has a unit. So take note of that. Good. Now there's what we call molecular formula. This also shows the actual number of atoms of different elements in one molecule of a compound. We'll look at this empirical formula. We'll look at this later. And then we'll have molar solution. We'll also look at molar solution. We also have the standard solution. We'll look at this when we are dealing with concentration of solutions. Right. Now let's look at the Avogadro's constant, or Avogadro's number, which is basically represented by the symbol L, and it represents 6.02 times 10 to the power 3 particles in 1 mole. Alright, so as I mentioned earlier, Avogadro's constant is defined as the number of particles in 1 mole of a substance. So as soon as you pick 1 mole of any substance, the number of entities will be equal to the Avogadro's number. Now there is a relation between the Avogadro's number, which is L, the number of moles, which is small n, and then the number of entities, or the number of particles in any given substance. We represent that one by the symbol capital N. And so let's look at that relation. And so we have capital N, which is the number of particles in a mole. So the number of particles in a given substance is equal to the number of moles multiplying the Avogadro's number. So from this relation, if small n, which is number of moles, is equal to 1, then of course the number of particles or entities, which is capital N, will also be equal to the Avogadro's constant or number. Right. You can play around this relation to have it in different ways. Whether you have been asked to look for the number of moles, you can just do your change of subject nicely and then off you go. Good. So let's look at some work example here. How many atoms are in 0.2 moles of calcium? How many atoms are in 0.2 moles of calcium? Now we have been given Avogadro's number, which is 6.02 times 10 to the power particles per mole. Now per the information that we have, we are looking for the number of atoms in calcium. Here the number of moles have been given as 0.2 moles, and Avogadro's number is also given to you. So as some of you have been saying, use what you have to get what you don't have or what you are looking for. So we are going to use the data given to us to look for what we are looking for. Good. And so this is the summary of the question. And then what do you think will be the relation that we are supposed to use? Now the relationship between these three quantities that we are looking for, one of them is that we have the number of atoms of calcium, which is the capital N, is equal to small n times the Avogadro's constant. And so when we do our substitution, we are going to have 0.2 for the number of moles. Please, when you are doing substitution, make sure you do a correct substitution. There is something we call correct substitution. Even though multiplication is commutative, so even if you turn it, the answer will be correct, but substitution is wrong. So in an examination, when marking is done, we mark for substitution. So make sure if you say n times L, your substitution will follow suit. Right. And so if your calculator is good, it should give you 1.204 10 to the power 23 atoms of calcium. What it means is that if I pick 0.2 moles of calcium, I am going to have 1.204 times 10 to the 23 power of atoms. So this is the number of atoms in 0.2 moles of calcium. I hope that is clear to you. If not, let's look at another one, then it will enhance your understanding. Right. Now the next work example that we are looking at is that how many atoms are there in 0.4 moles of hydrogen molecules? How many atoms are there in 0.4 moles of hydrogen molecules? Here the question demands number of atoms. However, the number of moles that was given to us was given in the term of the hydrogen molecule. And so, if you are doing with such a question, you have to be careful a bit here. You have to know what is into hydrogen molecules and what do we mean by the hydrogen atom and the relation between the two before you do a good job for us. And so the number of moles that was given was 0.4 moles for hydrogen molecule, which is the H2. And then, so the number of particles of the hydrogen molecules is given by the number of moles times Avogadro's number. Here, because I have given you the formula in the previous slides, in order to save time, that is why I didn't bring the formula again. But please, in any of your presentation, whether by exams or exercises or whatever, you try as much as possible to state your formula before you go ahead in your computation. Otherwise, you will lose some vital marks. And so the answer, we have 2.408 times 10 to the power 23 molecules. 23 molecules. Now the question is, do we end here? Do not forget that the question is demanding for hydrogen atoms, not hydrogen molecules. So we have to move ahead and know what is into the molecules. Now by this question we need atoms, as I've said. And so we have two, if you look at the number of molecules, the hydrogen molecule, we have 2 atoms of hydrogen in the molecule. So we have H2, which is the same as 2H. So we have to multiply the number of molecules that we had by 2. And that will give us 4.8 times 10 to the power 23 atoms. What it means is that every single molecule of hydrogen is giving us 2 atoms of hydrogen. And so, in 2.40820 particles of molecules, we have double of that number in terms of the atom. That is why we multiply by 2. So, note that H2 is 2H, and so one molecule of hydrogen is called 2 atoms of hydrogen. And that will bring us to this particular 4.8 times 10 to the power 23 particle that we have. Please make sure that you take note of that. Right. Now this is a trial question for you. So after you have gone through the 2 slides, you should be able to try yourself on this, and don't call yourself a master on anything that you have not tried. If you tried and you are able to do it successfully, then you can call yourself a master. Right. Let's look at, I told you in our in the beginning that we'll look at relative molecular mass in detail. So here we are going to look at relative molecular mass. Relative molecular mass. And so as I told you, once you see relative, it means we are making comparison with a particular reference material. And here our reference material is the carbon-12 isotope. So here, if you say relative molecular mass of a molecule of an element or a compound, you are looking at the number of times the mass of that particular molecule of that compound is as heavy as 1/12 the mass of one atom. Alright, here we are looking at relative molecular mass. As I told you, that I'll be looking at it in detail. So we are saying that relative molecular mass of a molecule of an element or a compound is the number of times the mass of one molecule of that particular element or compound is as heavy as 1/12 the mass of one atom of carbon-12. This looks, it seems to be a bit long or lengthy, but then the concept in there is not long. So here what we mean is that you are comparing how heavy or the mass of a particular molecule to 1/12 the mass of one atom of carbon-12. So if I take one atom of carbon-12 isotope and I divide its mass by 12, that becomes my reference material. So I am looking at how heavy a particular compound is in relation to that particular mass I have taken. So if I have, let's say, a molecular mass of a molecule as, let's say, 20, then it means that that particular molecule is 20 times heavier than 1/12 the mass of one atom of carbon-12. That is the meaning of this particular quantity called relative molecular mass. Right. So we are also saying here that it is similar to relative atomic mass in principle, but then they are not the same. The main difference here is that relative molecular mass deals with molecules, but that of relative atomic mass also deals with atoms. That is the difference between them. But the principle we use to determine the molecular mass and then the atomic mass, they are virtually the same, right, or similar. So mathematically we have relative molecular mass is equal to the average of one molecule of a substance, and we are comparing it with 1/12 the mass of one atom of carbon-12. All right. Good. We have some work example here for you to, or for us to share ideas together. So determine the relative molecular masses of the following. We have sodium chloride, we have sodium hydroxide, we have sulfuric acid or tetraozosulfate 6 acid, and then we have been given the relative atomic masses of the various atoms that makes up the various compounds. A good examiner or a good examination should give you or should provide you with this particular relative atomic masses. So we have 23 for sodium, 1 for hydrogen, 16 for oxygen, and then 35.5 for chlorine, and lastly 32 for sulfur. So we are going to look at how best we can move around these particular examples. So we take our A part, and in A part we are saying that sodium chloride, which is NaCl, contains one atom of sodium, and so its mass will be 23, and then one atom of chlorine, which has a mass of 35.5. And so as I told you from the beginning, the relative molecular mass you only determine by summing up the individual relative atomic masses that makes up the molecule. So we are only going to do a simple summation between the sodium and chlorine. And so we have 23 plus 35.5, that will give us 58.8. Notice that there is no unit attached to this. There is no unit attached to this because of the word relative. Because of the word relative, no unit is attached. Now the B part, we have sodium hydroxide, which contains one atom of sodium, which has 23 and then 1 atom of oxygen with 16 relative atomic mass, and 1 atom of hydrogen with 1. So here again, we are going to do simple summation, and so we are going to have 23 plus 16 plus 1, and that is giving us 40. Alright, I hope that is clear to you. If not, you have to start all over before you move to the next molecule, which is the H2SO4. Now, before I show you what I have done, let me ask you how many hydrogen atoms are in that particular H2SO4, how many sulfur atoms, and how many oxygen atoms. And so, if you are able to give me what I have shown you, then you are correct. So we have 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. So I have 2 times 1 for hydrogen, 32 for sulfur, and 4 times 16 for oxygen. So I am going to have 2 plus 32 plus 64, and that is giving me 98. Here again, there is no unit attached to this quantity. Take note of this. Now, we are also going to look at molar mass. Molar mass, I would say, is a sister to relative molecular mass, in the sense that quantitatively they are the same, but they are only difference in that molar mass will have a unit, but molecular mass, relative molecular mass, has no unit. So once you see the word molar, there should be a mole in your mind. There should be 1 mole somewhere in your mind once you see the word molar. Not molar as in tooth, but molar as in chemistry. So molar mass of a substance is the mass of just 1 mole of that particular substance. So if the substance is not 1 mole, then the mass will not be called molar mass. But as soon as the amount of substance is 1 mole, then its mass is also called molar mass. So you take note. The unit is gram per mole. Gram per mole. So we say that molar mass of a substance you only determine by just summation of atomic masses of individual atoms that makes up that particular substance. So this is just similar to relative molecular mass. Here we still sum the individual atomic masses. The difference here again is the unit that will be attached to this, right? So numerically it is equal to relative molecular mass, but let's see. We are also saying here that molar mass relates to amount of substance. There is a relation between molar mass and the number of moles, or the amount of substance, and it is given by mass over molar mass. So we are saying that number of moles is equal to mass over molar mass. Or in other words, if you do a change of something, you can have molar mass to be equal to mass over the number of moles, or the mass, which is the small m, is going to be equal to number of moles times the molar mass. So depending on whoever and the type of question that is available to you and the type of information given, you manipulate this relation to suit the content of the information given to you. Good. So we are saying that the small n represents amount of substance, the small m represents mass of a substance in grams, and then capital M also represents molar mass in gram per mole. Now let's look at work example. If you remember, when we were doing the relative molecular mass, we looked at that of H2SO4. We are going to do our calculation here and see if it will be the same, and we'll tell you the only difference. Alright, so let's look at how we can do our calculation. So as we saw in the case of relative molecular mass. Here again we have the mass of hydrogen, which is 1, multiplied 2 by the 2 atoms of hydrogen that we have in H2SO4, plus 32 for sulfur, and then plus 16 times 4 for oxygen. And so with our calculator or whatever tool we are using, is going to give us 98 gram per mole. And when you go back to relative molecular mass, you saw that we also had 98 without a unit, but this 98 is gram per mole, and that is what brings about the differences, or the difference between the relative molecular mass and then the molar mass. So take note of the two. Now we looked at another example which said that calculates the molar mass of calcium hydroxide. We have given you H for 1, O which is for oxygen 16, and then calcium for 40. Now you were not given the molecular formula for calcium hydroxide, and so that is the only work that you are supposed to do. And if you are not able to write a good formula for calcium hydroxide, then you will find it difficult to continue. So, but at least the relative atomic masses given to you should inform you about the various atoms that makes up the calcium hydroxide. And so if you are able to write it as Ca in bracket, OH close bracket, and then 2 outside the bracket, that should inform you calcium hydroxide. Calcium hydroxide. The 2 outside is telling you about the ion Ca, the charge on Ca, and then the charge on OH is -1. So when you do your combination, this is what you have for now. Later we will do more of this chemical formula writing, right? So if you do your substitution, here again we have 40 for calcium, and then 16 for oxygen and 1 for hydrogen, and the 2 outside we bring it, and then we have 74 gram per mole. 74 gram per mole. So if it were to be relative molecular mass, you have 74 without the gram per mole, right? Now another example, we have calculate molar mass of sugar. By this time, this examiner is good and has given us the molecular formula for sugar as C12, H22, and then O11. And then the atomic masses have also been given. So we go straight to do our substitution and we look at what we have. So the the molar mass, we have 12 times 12, that is 12 for carbon, and another 12 for the number of carbon atoms in that particular molecule. We have 1 for hydrogen and 22 from the number of hydrogen atoms. And lastly but not the least, we have 16 for oxygen and then 11 for the number of oxygen atoms in that particular compound. And again, that will give us 342 gram per mole. So we are saying that the mass of 1 mole of sugar is equal to 342 grams. That is the meaning of 342 grams per mole. So sometimes we can ask you that what is the significance or the meaning of 342 grams per mole. It means that the mass of 1 mole of sugar is equal to 342 grams. So take note of that. Now, here we are looking at molar mass of 0.025 moles of carbon oxide gas, which has a mass of 1.1 grams. Now this particular example is a bit different from what we have done so far on molar mass, in a sense that we were not given the relative atomic mass, but then something different has been introduced as the moles and then mass. So here, per the information we have, we'll use what we have to get what we are looking for. So we are not going to use the atomic masses because we were not given, but we are going to use the information we have. So let's see how we are going to employ the services of these two data given to us. Right. Now, if you remember, when I started talking about molar mass, I gave a relation between molar mass and then amount of substance, as that molar mass will be equal to the mass divided by number of moles. Mass divided by number of moles. So this is what we are going to employ. And so that will give us 44.0 gram per mole. You can compare this with using the atomic masses of carbon and oxygen, and you will realize that your answer will be the same as this one on the board. Alright. Good. So this is a very nice trial question for you. You see, I've been telling you, don't call yourself a master on something you have not practiced. So if you practice this and then you are able to have it well, then you can go ahead. So this is a table that you are supposed to complete, and if you're able to complete this table, then you can go ahead. It will inform you about how best you understand molecular mass and then the molar mass. So I have given you the various compound names. We have sodium hydroxide, calcium tetraoxosulfate 6, we have glucose, sorry, we have carbon 4 oxide. Now, intentionally, I didn't give you any of the molecular formula, so you are supposed to look for the molecular formula. And then the atomic masses have been given to you. And for that of carbon dioxide or carbon 4 oxide, I didn't give, because basically, if you know the formula, what is on the board can help you to calculate for the molar mass and the rest. That is why I didn't waste time to give you the molecular, so the atomic masses of carbon dioxide, the various atoms in that. So you are to complete it by calculating your molar mass and then the relative molecular masses. So you will then tell your observation as far as the computation for molar mass and the relative molecular masses are concerned, and that will let you understand the difference and then the similarities between the two. Good. Alright, now this is also a trial question for you. You have been given sodium chloride, ammonium sulfate, copper 2 sulfate, and all the atomic masses of the various atoms involved. You are to calculate the molar mass, and then the try question 2 also that calculate the number of molecules in 6.4 grams of sulfur 4 oxide gas, and the various information you will need to do your calculation has also been provided. So having been able to go through this successfully, it will inform you on how best you have understood what we are dealing with. Good. There are times you will be asked to look at the number of moles in a given mass of a substance. Some that a certain or a given mass will be, and then you will be asked to look at the number of moles in that particular entity. So for instance, we have 5 grams of sodium hydroxide, we have 13.05 grams of H CH3CH2OH. That is basically C2H5OH. That is ethanol. That's the standard form of the formula for ethanol. You can also have 1.2 grams of HNO3. That is nitric acid. Then how many moles are present in this particular quantity given to us in gram? Good. So we are not going to do anything, but we are going to employ the services of a relation that we have given already. And so before that relation will be available to us to use successfully, we need to look for the molar mass of sodium hydroxide. And when we have our molar mass and mass, I believe now you know the relation we are going to use to do our calculation. And so we have number of moles as mass over molar mass. So we have 5.0 divided by 40, and that is giving us 0.125 gram per mole. I intentionally brought the unit so that you know which unit is off and which unit will be left. So if you know your unit, you can decide to ignore them, but bringing them on board will help you to know which ones are going away. So you see that the gram will cancel the gram down, and then the mole, which is dividing the gram again, will move up to be 0.125 moles. I believe that is okay with you. Now, having understood the concept, I will ask you to work the various steps for B and C. I have given you the answer. So you work it out and compare your answer with what is being provided to you. The process or the steps you are to follow is the same as the A. That is why I didn't want to bother you with too much words on the slide. So you yourself work it out and then you compare your answer. If it's wrong, just look at the steps very well and you'll be able to do that. Again, there are times you'll be asked to calculate for mass. If you were to be in school, or if we get to how we can prepare solutions, then you will definitely need to know the mass, because you have, let's say, sodium chloride in a container, and then you are to ask to prepare a certain amount or certain concentration. You need to know how much of the ones in the container you should fetch. And so this very relation or this very formula is very important, so take note of that. When we get to concentration of solutions and the rest, we will revisit it again. Okay, so we have N, which is number of moles, equals mass over molar mass. And this will imply that if you remember your change of subject in mathematics, then it will inform you that small m, which is for mass, will be equal to small n for number of moles times the big M for molar mass. So take note of how we will use this particular relation. Now, let's see our work example. Find the mass of 0.5 moles of ethanol. 0.5 moles of ethanol, C2H5OH, and the various atomic masses have been given to us. Right. So we have number of moles 0.5, and then molar mass of ethanol, we have 12 times 2, and that will give us basically 24. We have 1 times 5, which is 5, and then 16 plus 1. And that is giving us 46 grams per mole. That is the molar mass. And so, using the formula M is equal to small n times big M for molar mass, we are going to have 23 grams. 23 grams. And of course, this makes sense because our number of moles is 0.5, which is half of 1 mole. And if the number of moles were to be 1, then the molar mass will be 46, the mass will be 46, which is equal to the molar mass. But because the number of moles is 0.5, which is half of it, then definitely our grams should also be half of 46. So if you do yours and it is not 46, then it should inform you that you are, or something is wrong somewhere in your calculation. So in as much as you do some of this calculation, you have to follow it keenly and realize that if you are wrong, you can easily see it. Right. Good. These are trial questions for your consumption, and I believe this is good for your consumption as well. It is very good for you this time that COVID-19 has kept you in the house. This is very good for you. In as much as you are enjoying the breeze in your house, try as much as possible to do all the trial questions in the slides. Right, so we have find the mass of 0.5 moles of ethanol, calculate the number of molecules in 6.4 grams of sulfur for oxide, calculate the number of molecules or particles in the following mass of substances. So I believe this is very good for you. Alright. Thank you very much for your attention. I believe the lesson has been successful.